Today we are going to learn about the naming of organic compounds. In last class I have started the naming and we have completed the part for hydrocarbons. Hydrocarbons, that means especially for alkanes, but not for other hydrocarbons like as unsaturated hydrocarbons. But today we will learn about the naming of organic compounds, precisely if I say alkyl halides and alkenes and alkynes. So I have two different learning objectives, class learning objectives. Here you can see CLO. For every class we have some objectives and we need to provide this information to the UGC that what we are going to teach for every class, and we need to get out that some output that if we could succeed to get the objectives by outcome. So our teaching system is considered as learning outcome based learnings, OBS, like this way, outcome based learning system. So always we need to understand what we are going to learn, what is our target, and what we will learn after the end of the class. If you get the idea or not, that is our target, because we want to have some target and idea so that we can understand what we are going to learn. Okay, so from the first we are going to learn, as I have mentioned, that one of the learning outcomes or objective is naming of alkyl halides. This is very short thing, just only this slide I will cover up, and then for any organic compound or halide compound or alkyl halide, if you have an halogen, in that case you need to consider this is as an substituent. Substituent, that means as a side chain, but as this is only one atom, in that case we don't need to think about the side chain or branch, just we will consider as a substituent. That means one hydrogen is replaced by one halogen. So how we will name the compound? In that case the halogen is treated as a substituent on an alkane chain. That means last class I have mentioned regarding the hydrocarbons or alkanes, naming of alkanes. So in naming alkane, just I am going to mention little bit, just there are a lot of new students, so just little bit, we always need to remember or need to memorize few names of the hydrocarbons or alkanes containing significant number of carbons. How many carbons you have in an alkane, you have to memorize the names depending on how many carbons you have. If you have one carbon, you need to memorize this is for methane, 2 ethane, 3 propane, like this. So you have to memorize few names, but most of the case you don't need to memorize anything regarding science except few of them, some exceptional case, because if you do not know my name, then you cannot recognize this is your biochemistry or bioorganic chemistry teacher or physical chemistry teacher. So if you are familiar with my face, that is fine, but if you want to mention me that this is our biochemistry bioorganic chemistry teacher, then you have to remember my name. So always you need to remember some names and you need to memorize. So that is one of the main criteria for naming of any organic compound. And then we have shown how we can follow the numbering. That means from which direction we should use the numbering. We can, first of all, we need to consider maximum number of carbons. In which direction we have the maximum number of carbons. In that case, just we will number from one side, and then we can number from other side also, but it will depend which one is correct. We have some other rules that already I have mentioned, that if you have the branch or side chain, if you number from one side, how many side chain or how many branch you have, the summation of the position of the side chains should be minimum. So These are very simple rules I have given in the last class, and I have mentioned with several examples. So if you those who are present, I think all of you are already learned about that, and also you are familiar with the naming since you was a student of science group in intermediate level, and you also have the organic chemistry. So just we are going to repeat the rules, but many of you do not have the background in English medium or English version, so some of them may have difficulty in English. However, I am going to use very simple English because my English also is not very high level. So I think the English will be not very difficult. However, if you have any difficulty to understand, please feel free to ask me any question. So I can even use Bengali, no problem, to make you understand. I want to make you understand by anyhow. There is no restriction of language, just I am trying to follow English. However, if you have difficulty in any specific topic, then I can cover that one in Bengali, or even if you have any question, then I can make you understand in Bengali if you need. Okay, so if we want to name the alkyl halides, just we will treat the alkane or halogen like as a substituent. The halo-substituent is considered of equal rank with an alkyl substituent in the numbering of the parent chain. The halogens are represented as follows. If you have a fluorine, then you need to rename or name in the organic compound fluoro, chlorine, chloro, bromine, bromo, and iodine, that will be represented as iodo. So if you have any compound containing halogen, which halogen presented there, just you need to use that types of words to name the alkyl halide compound. Let us see the example. This is an example of an alkyl halide. So first of all, we have to think about the numbering. In last class I have mentioned about the numbering. So 1 second. Okay. So numbering, I have mentioned that the branch or substituents, how many substituents we have. This is one chlorine and this is one methyl, or even we can consider this can be considered as a branch or side chain or substituent. So if we consider this is side chain, that is okay, or this is side chain, that is also okay. Why? That is because this position, if you consider the ring by this way, that is how many number of carbons we have, 1 2 3 4 5 6. So if you go straight, that also gives you the 6 carbons. So there is no difference between this, either you follow this way or you follow this way, or even if we go by this direction or by this direction, that also gives the maximum number of carbon in the chain. So how we should give the number? So first you have to think about the summation of the position of the substituents. How many substituents we have? We have 2 substituents. If you have one substituent, then you should consider the minimum number for the position, but if you have multiple substituents, then you need to think about the summation of the position of the substituents is minimum. So let's count. If you consider the numbering from right side, then number 1 2 3 4 5 6, or this is 6. So in that case we are having the position for the substituents, this is 4 and this is 5. So 4 plus 5, we are getting 9. So we are getting one option. We are getting one option. So if we have the numbering in other way, that means if we start from the left, start from here 1 2 3, that means we are having one side chain or substituent in the 2 position and another one in the 3 position. So we are having the summation of the substituent number. This is 2 plus 3, only 5. But from right side we had the summation was 9. So if you number from right side, that do not follow the rule from the IUPAC what they have mentioned. So what is our rule? We should remember that the summation of the position of the substituent should be minimum. So as minimum or as low as can. If you have more substituents, in that case you can have, maybe you can have one here or here, that is also okay. But you need to find out the root minimum, not the less, just minimum. You need to find the minimum number of the summation. So here you have the methyl group and the chloro. So two substituents, if you have two different substituents, then you have to write down the number of the position of the substituents. So what are the substituents? Chloro and methyl. So in last class I have mentioned regarding this, if you have two different substituents, then you have to write down the name giving the preference alphabetically. So you have two different substituents, chloro and methyl. So alphabetically, chloro, that means it starts with C, and methyl starts with M. Therefore you should write down the name chlorine or chloro first and then the methyl, because alphabetically we can see that C comes first and M comes later in this name. So we should follow the naming position of chlorine or chloro first and then position methyl later, and then the parent carbon or parent hydrocarbon. So how we are writing here 3-chloro. Why 3-chloro? That is because the position of chloro substituents or chlorine substituents is 3. So we are numbering by giving the position 3 and then one hyphen and writing the name of the substituent chloro, and then again giving another hyphen, then giving the position of the methyl group or methyl substituent. This is the position 2, this is 3, so this is the position 2, and then again giving another hyphen. Finally the methyl, this is the substituent. So 3-chloro 2-methyl, and how many carbons we have? Maximum 1 2 3 4 5 6. So 6 carbon, that will be renamed as heptane. So this is one of our compound.
Sir, 6 carbon, sir. Hello, sir. 6 carbon হলে হেক্সেন হওয়ার কথা না?
Oh, sorry. Yes, sorry.
Sir, তো হেক্সেন হবে.
Yes. What happened? Mouse is not working. Okay. Sorry. Thank you very much for correction. Okay. We have 6 carbons. 1 2 3 4 5 6. 6 carbons, so it should be named as 3-chloro 2-methyl hexane. Okay. So we are not going to give in detail more or anything. If we have some other names in our during our study of several chapters, then we will name that compound if we have many more alkyl halides. Now we will go for the naming of unsaturated hydrocarbons, that means alkenes and alkynes. So for alkane, we have memorized the names of hydrocarbons containing the number of carbon, like as methane, ethane, propane, butane, pentane. All are, you need to remember the names. In case of alkyne or alkenes, this is unsaturated hydrocarbon. Therefore unsaturated hydrocarbon, if you have the double bond, that is unsaturated or the alkene, and if you have triple bond, in the next slide I will show you the triple bond. So for double bond, you have to rename the First, consider the name of the hydrocarbon or alkane. This is our alkane or parent compound, and if you have a single double bond in that compound containing two carbon, in that case you need to replace this ane. For any hydrocarbon or any alkane, you should follow this rule, ethane. That means if you have two carbons or hydrocarbon or alkane containing two carbons is known as ethane. So the spelling for ethane is ethane. Now if you have one double bond in one compound having two carbons, in that case that is considered as alkene. So naming of alkene, you should replace ane by ene. So just remove the ane and replace by ene. That will give you the name of your respective alkenes. So ethane we have. Now we can rename the compound alkene as ethene. For any alkene you should follow by this way until we have double bond or triple bond. If you have single bond, single double bond. If you have multiple double bond or multiple triple bond, in that case we will change little bit. I will mention in the next slides. So if you have single double bond or triple bond, in that case for double bond we will mention or we will change the name by ane will be replaced by ene. Mean ethane and then propene. This is carbon, 3 carbon containing alkenes. So in case of alkynes we will write down yne in the place of ane. In the next slide I will show. So if there is more than one double bond, if any compound, unsaturated compound, especially for alkenes, if you have more than one double bond, it can have 2, 3, 4, how many, doesn't matter. So if you have more than one double bond, the suffix is expanded to include a prefix. Suffix, that means what comes later, and prefix what comes first. So if you rename, if you consider my name is Madhusudan Roy. So first name Madhusudan or personal name, Roy is my family name, or you can consider this is a suffix, and first name is prefix Madhusudan. So you can consider or first name last name this is this way. So if there is more than one double bond, if you have multiple double bonds, in that case the suffix is expanded to include a prefix that indicates the number of double bonds. How many double bonds you have in the alkene? If you have double bond, 2 double bonds, then you need to consider this is di. So how you have the alkyne, 2 alkenes or 2 double bonds, in that case we have to replace ane by adiene. If you have 2 double bonds, adiene, ethane, and then it will be ethane diene. So it is not possible because in case of ethane we cannot have 2 double bonds. So we need to have at least 4 carbons to have 2 double bonds at least. So otherwise we cannot have. So in 1,4-butadiene, this is one of the examples, or 1,3,5 hexatriene. I did not show you the example here, the formula name I have given, but in the next slide I will show you. So if you have 2 double bonds or 3 double bonds, you need to replace the ane by adiene or atriene. If you have 3 double bonds, then atriene, and if you have 2 double bonds, adiene, or if you have 4 double bonds, then atetraene, like this way. So if you have single double bond, then just rename, changing the ane of the alkane by changing with ene, that will give you alkene. And if you have multiple double bonds, in that case you need to add adiene for 2 double bonds, A triene for 3 double bonds, or A tetraene like 4 double bonds, like this way. So triple bonds are named in a similar way. As already I have mentioned, for alkene exactly similar, except previously we have mentioned that we have changed ene in case of ane. For alkane we have propane ane, and we have changed for alkene by ene, but in case of alkyne we have to change by yne. So here you can see this is our 3 carbon containing alkyne, therefore we can consider the parent hydrocarbon or parent alkane is propane. So this is our propane, and from propane we are getting, if we replace with yne for ane, then we will get propine. So you don't need to but sometime the position of the triple bond or double bond can be in the middle or somewhere else, not at the end. In that case you need to mention the position of the double bond or triple bond. Here is the position of the multiple bonds within the parent chain are indicated by placing the numbers of the first carbon. Let us consider, for this molecule we have a triple bond in this molecule. So if you have the double bond or triple bond just at the end, that means in one side of the molecule, in that case you don't need to mention the position. Why? This is our rule. The position of the multiple bonds within the parent chain is or are. That means if you have multiple, that means 2 or 3 double bond triple bonds, then are, that means if you have multiple bonds, that means double bond or triple bond in a compound, and then within the parent chain is indicated by placing the numbers where the position, if the triple bond was, for this molecule, if the triple bond is in between this carbon and this carbon, then this is named in one way, and if the triple bond comes to the middle of this carbon and this carbon, in that case that compound will be different. So we need to show the difference in naming also. Otherwise if we have the triple bond in between this carbon and this carbon, if we consider that is butane, that is okay but not accurate. So this, if you have one triple bond in a compound having 4 carbon, that is definitely butane, but to make you precise or accurate, you need to mention the position of the triple bond also. So how we can mention the position of the double bond or triple bond? Just find out the double bond or triple bond and number the first carbon. That means if you have the triple bond in between these 2 carbons, so if you number the numbering of the carbons from this direction 1 2 3 4, in that case you have the triple bond in between carbon 1 and carbon 2. So you need to mention the position of the carbon as carbon 1. For here, if you have the numbering like this way in this direction, that will be given carbon 1 2 3 4. So in that case the position of the triple bond is in between carbon 3 and 4. So you need to mention the position as 3 because we have mentioned the first carbon you need to mention. So you don't need to mention both carbon while you are mentioning a double bond or triple bond. Just mention the first carbon in the or attached to the double bond or triple bond. So here we have one triple bond, so we should mention the position of the triple bond in this way, that we the adjacent carbon, how many carbon, at least 2 carbons will be adjacent, so we need to mention the position of the first carbon. Now I have mentioned the numbering by this way and this way. which one is accurate? As we have mentioned, if you have any functional group or side chain, in that case you need to give the position of the double bond or triple bond smallest. So from this side you should have the numbering from right side. So 1 2 3 4. So we are getting the position of the functional group or alkyne or triple bond in the first position, and if you number by this way you are getting the third position. So from the left side that is not accepted. If any of you have question or I'm getting some noise, please mute yourself if you do not have question.
No, sir.
Yes, someone, I'm getting some noise. So if you do not have question, please mute. And if you have any question, that time just turn on and then ask question. Okay. Okay. Then we are numbering and we are mentioning the position. Now, if you have the triple bond in between these two carbons, carbon 2 and carbon 3, or you can number by this way, that is also okay. So carbon 2 and carbon 3. So you need to mention the position of the triple bond. If you do not mention in case of this one, that is okay, because we don't need to mention the position for one. Anything, carboxylic acid, alkyl halide, or any other aldehyde or whatever. Most of the case, if you have any functional group or any branch or anything in the first position, you don't need to mention the number. That means if you do not mention the number of the position, then always we understand this is in the first position. So you don't need to mention. Okay, so if you have the double bond in between these two carbons, then that is quite different from the position from here. So that two compounds will be quite different in their physical and chemical properties. In that case, we need to mention the position of the triple bond to distinguish between these two hydrocarbons or two alkynes. So you need to mention the position either. In that case, you have the carbon adjacent carbons 2 and 3. So you need to mention the name by this way. CH, that means butane to butane. To butane. To butane, the triple bond position of triple bond is in the 2 position or in between 2 and 3. So you need to mention the 2 butane like this way. So what is the message? Okay, now here is one example. The position of the multiple bonds within the parent chain is indicated. This is not for your personal chat room, please. This is class, and I will open or I will add you in a WhatsApp group, and in that group you will not allow to discuss any of your personal things. এটা একটা ক্লাস, সেখানে সেটা তোমরা মনে রাখবা, এই পার্সোনাল, এটা তোমার পার্সোনাল নয়, এটা তোমাদের শুধুমাত্র ইনফরমেশন। আমার সাথে তোমাদের ইনফরমেশন কোনো কিছু দেওয়ার যদি থাকে, শুধুমাত্র এই পারপাসেই গ্রুপটা। এবং আমি এখন ক্লাস নিচ্ছি, এই যে এই দিচ্ছ ওই লাভ রিয়াক্ট এখানে না দিলেও চলবে। হ্যাঁ, এটা তোমাদের এইসব কাজের জন্য না। তো আজকে তো প্রথম ক্লাস, তো আজকে আমি বলে দিলাম, আশা করি এরপরের থেকে তোমরা এটা ফলো করবা। ঠিক আছে? গ্রুপ, যে কোনো গ্রুপ, সে যে কোনো গ্রুপে হোক না কেন, সেখানে তোমাদের পার্সোনাল ডিসকাশন যদি কারো কাছে সাথে থাকে, পার্সোনাল মেসেজে পার্সোনালে টেক্সট করবা। কখনোই গ্রুপে কোনো পার্সোনাল কথা বলতে যাবা না, আর অযথা কোনো প্রয়োজন ছাড়া কোনো মেসেজ গ্রুপে দিবা না। কারণ প্রত্যেকটা মেসেজ প্রত্যেকটা গ্রুপে নোটিফিকেশন হিসেবে যায় এবং সেটা যার প্রয়োজন নেই সে বিরক্ত হয়। এই কারণে পার্সোনাল কোনো কিছু দেওয়ার দরকার হলে সেক্ষেত্রে পার্সোনালি যাবা। আচ্ছা, the position of the multiple bonds within the parent chain are indicated by placing the numbers. If you have 2 or 3 multiple bonds or double or triple bonds, in that case you need to mention the positions at, even if you have one double bond or one triple bond but not at the one position, in that case you need to mention also. But if you have 2 or 3 multiple bonds in a single compound, in that case you must need to mention the positions with comma and then put the name of the parent compound, and in that case you need to follow, that means of the first carbon of the multiple bonds directly in front of the base name. So you have the base name, this is hexane. This is the, if you have 6 carbons, 1 2 3 4 5 6, so if you have 6 carbons, then the name of the alkane is hexane. So if you have double bonds, that should be hexene. Now you have 2 double bonds, so you have to mention that diene. So how you will use the diene word? Using the hexadiene. So where the position of the double bonds? This is in between 1 and 2, so you need to mention the position 1, and this is 3 4, 1 2 3 4. So in the 4 and 5, in between 4 and 5, you should mention the position as 4. So the name of the overall compound we are writing here as 1,4-hexadiene. So diene, this is for 2 double bonds, that means 2 hydrocarbon containing 2 double bonds, that should be diene, and the parent compound is hexane, so it should be hexene if we had only single double bond, but now we have 2 double bonds, so we should write down as hexadiene in this form. Okay, the parent chain is numbered so that the multiple bonds have the lowest numbers. Okay, if you have the multiple bonds, so you need to number the hydrocarbons in that way that the multiple bonds have the minimum number. So, and the lowest numbers, double and triple bonds have priority over alkyl and halo-substituents. That means if you have a alkane, and that means if you have a double bond or triple bond, in that case you need to consider either this is an alkene or alkyne. But normally in case of alkane, the least priority for the naming of hydrocarbons or carbon compounds is the alkanes. If you do not have any functional group, any side chain, or any double bond, triple bond, or any other thing, in that case you need to consider that the hydrocarbon or alkane, it can have the cyclic hydrocarbon or cycloalkane or normal or N-alkane. So if you have any functional groups except alkane or carbon-carbon single bond, in that case you need to give the preference for that other functional groups over the haloalkanes or what we have. So we need to think about the numbering. So let's this compound, how we can number the position of the this carbon. Already I have shown you, but how you can number the parent chain is numbered so that the multiple bonds have the lowest numbers. So this is the compound. We have 2 double bonds, 1 2, and if you number by this way, 1 2 3 4 5 6, if you number by this direction, then what is the position of the multiple bonds? You can see in between 2 and 3, so we have to number by 2, and in between 5 and 6 we have to consider the 5. So the position of the double bonds, the sum of position of the double bonds is 2 plus 5, that means 7. So this is one way of numbering, but if we follow this numbering, then what is the summation of the position of the double bonds? This is 1 and then this is 4. 4 plus 1, that means we are getting 5. So which one should be perfect? Anyone? Which one should be followed?
Second 1 plus 4.
Second one.
1
Okay,
plus
yeah,
4.
yeah, the black
Sir,
numbering.
right.
Black numbering.
Yes, sir.
Yeah. Okay, thank you. So let's ask another question. Then what can be the name of this compound? You have number.
1
Yes.
1
4.
4 diamine.
1
1
4
for di.
1
Di.
for
Hexadiene.
1 for
1 for-
hexadiene.
1 for hexadiene.
Just previous slide what I have shown, exactly same thing. Here I didn't show you the numbering, so just I have added the numbering here, and here I have shown how we should number. So we are getting the 1,4-hexadiene. But we also can name by this way, but that is not perfect. So we should not follow the red marking here or not this name. So we should write down hexadiene, 1,4-hexadiene, not 2,5-hexadiene. Okay, for next rule, when both double and triple bonds are present, that is little bit confusing. If you have a compound including one double bond and one triple bond, or multiple double or triple bonds, in that case it is little bit difficult to consider what should be the original compound. Here we have two different rules, but exactly I cannot give you when the numbering, but I think I have some idea. If you have multiple bonds for any compound, multiple double bond, in that case you should consider as the parent compound, or here you can see both the case we are having the name ine as the pentene 1-ine. So first let's see the rule. When both the double and triple bonds are present, numbers as low as possible are given to double and triple bonds, even though this may at times give ine a lower number than in. That means here I have given one idea. When both double and triple bonds are present, numbers as low as possible are given to double and triple bonds. That means you need to think about the position where the double or triple bonds are there, and minimum number you should, the summation, wherever we say the minimum number, you will see or you will consider the summation of the numbers. So position of the numbers, here you can see the position of the multiple bonds. This is 1 and here we can have 3. But if you number from left side, you can have this is 2 and that will be 4. So if we number from left side, that should not be perfect, because in the rule we have given the rule or mention regulation that we need to give the numbering minimum for the position of the double or triple bonds. So we should follow from the right side. So this is 1 and by this way. Now what is the name of the compound? We have one double bond and one triple bond. So in that case we should consider which one should be the parent compound or original compound, and what should be considered as substituent. So if you have double bond or triple bond, sometimes we can consider double bond as parent compound and sometimes triple bond as parent compound. So here I cannot give you the exact way when you should consider as double bond as parent compound and when you should consider the triple bond. So this is little bit difficult, not difficult, confusing. So I think IUPAC should clear this, as this is not given by me, so I cannot give you the exact way. However, most of the case we will follow the triple bond as the parent compound. So here you can see, so most of the case, not always, not 100%. So if you have any compound containing double bond or triple bond, in that case just we will write down as a triple bond or the ion compound as parent. So here we are getting that CH3, so we have one double bond and one triple bond. So how we will number the compound or name the compound? For this one, the 3-pentene. One thing in case of single double bond, we have mentioned the name. In the next slide I will show you the rule why you should name this way. In case of single double bond, here you can see, not this one, here triple bond, this one we have written ethene. Ethene, that means ETHENE, last ENE. But now when we are writing the name of this compound, here we have one double bond and one triple bond. Here we do not have the E. Pentene, we do not have the E. So this is our rule. When both double and triple bonds are present, then ENE suffix follows the parent chain. So parent chain at end, after end we do not need to put E. Here is the, you don't need to put the E, just write down the up to N. That is the rule if you have multiple double bonds or triple bonds. But if you have single double bond or triple bond, in that case you need to write down as ENE. But in case of double bond, multiple double or triple bond, you need to write down up to N, not E. So you need to write down the name up to the parent, suffix. You need to name the suffix up to En. So pentene, no E. So here 3-pentene, 1 ion. So the position of triple bond is in between 1 and 2. So we should name the compound as 3-pentene, no E. We do not have E here. So -1 and ion. So this is the name of one compound. And for this one, so 1,3-hexadiene. 1,3-hexadiene, 5 ion. So how many double bonds? We have 2 double bonds. So here we have one double bond, one triple bond. But here we have 2 double bonds. So already I have mentioned in previous slide that if you have 2 double bonds or 3 double bonds, in that case you have to mention diene, triene like this. So just a second. Okay, if you have 2 or 3 double bonds or triple bonds, in that case you have to mention diene or triene or tetraene like this way. So we have 2 double bonds, 1 and 2. So just mention the position of the double bonds by comma and then hyphen, and then mention the parent name. What is the total number of carbons? 1, 2, 3, 4, 5, 6. So it should be as hexane. So we have the double bonds, 2 double bonds. In that case we need to mention as diene. But as it has multiple bonds, double bonds, triple bonds, therefore it should not have the E at the end of the suffix for diene. So 1,3-hexadiene and 5 ion. So one very important thing, that you need to give the name as a word. There is no space in between the name of the compound. Whatever the compound is, even the name of the compound is very big, even in that case the name is just as a single word. That can be prefix, suffix, whatever, but there is no space in between the name. So there is no position of the blank. So here we have used comma or hyphen, 2 hyphens, but no space. So the name is always considered as a single word. So always you need to remember that the name is just like as a single word. Okay. So already I have mentioned, when both double and triple bonds are present, then you need to put the name as up to suffix like as en, not ene. So for a branched unsaturated acyclic hydrocarbon, if you have a branch, if you have a branched unsaturated acyclic hydrocarbons, the parent chain is the longest carbon chain that contains the maximum number of double and triple bonds. So if you have a compound with branch, it can have 2 or 3 branches. So however, if you have the branch, the parent chain is the longest carbon chain that contains the maximum number of double and triple bonds. So if you have a compound with multiple double or triple bonds, that means 2 or 3 double or triple bonds, and also branch, in that case what you will consider, the chain or direction along which you have the maximum number of double or triple bonds, you will consider as the parent carbon or parent compound. So if there are 2 or more chains competing for selection, so if you have a compound competing, that means in same direction, in 2 different direction, you have the same number of carbons, then what you have to consider, in that case you need to think about the position of the side chain or branch. So if there are 2 or more chains competing for selection as the parent chain with the most multiple bonds, the choice goes to, you have to follow the rule, the chain with the greatest number of carbon atoms. So the way in which you have the most number of carbons and the number of carbon atoms being equal, the chain containing the maximum number of double bonds. So if you have the compound maximum number of double bonds, in that case you will consider that the parent compound. So let's see, for this compound you have one double bond and at least 2 side chain or 2 substituents. So how you should name the compound? Anyone have the idea how we can name the compound?
Sir, double bond যেখানে আছে ওখান থেকে নাম্বারিং শুরু করব।
Okay,
then ওখানে যাব, সাইড চেন যেখানে আছে ওখানে দিব 1 2 3 5 dimethyl,
5
dimethyl,
not only 5, if you need to 5
yes,
yes,
5 dimethyl.
Okay, then
let's see,
yes,
one hexane.
Okay, one hexene. You should have E in the end because we have only one double bond. Okay, that's good. So as already we have shown the rules, now we will have another big compound. Now we have one double bond, 2 double bonds and 1 triple bond and side chain or branch 2, at least 2. So we have several way of numbering. Let's see how we can number. Already shown 1. So 1 2 3 4 5 6. Again, if you consider the number by this way, 1 2 3 4 5 6 7 8, in that case how we should number, how we should name? Already we have mentioned in the rule, you should follow, if you have the multiple double bonds or Yes, what?
Longest carbon chain, no?
Longest carbon chain, if it is competing. Let's see the rule again. For a branched unsaturated acyclic hydrocarbon, the parent chain is the longest carbon chain that contains the maximum number of double and triple bonds. So, if you have a compound with double bond or triple bond or multiple double bond or triple bond with branch, here we have the branch, is it? We can consider this one as branch or this one as branch or this one as branch, but we need to think about the maximum number of double or triple bond should be the parent compound. In that case, we have, if you consider the numbering like this way, 1 2 3 4 5 6 7 8, that should not be followed, because if you consider the parent chain like
So
this
then
way,
it
that we
starts
have
from
only,
1.
yes,
It starts from 1 and
right
goes
side,
down. Yes,
down.
right side down and
No.
down. No?
In that case, you should have the maximum number of double or triple bonds in the chain or
Oh,
parent
triple
compound.
bonds. Yes. Oh, yes.
So, the number what I have shown here, that is the exact way of numbering. However, we can choose other options that we can have or not. So, the numbering what I have shown here, that is perfect. However, let's see if we consider by this way. Let's come by this way. 1 2 3 4 5 6. So it has 6 carbons, but we have only one double bond in the compound. Yes. Then if we go by this direction or by this way, in that case we also have only one carbon double bond. Again, if we go by this way, from here to this way, you have another class? Oh, sorry, yes. Just this is the end. This is the end slide. So let's finish the naming. So see the name. We need to follow. This is the parent compound. That means we have 3 double or triple bonds, 3 for dipropyl. That means these are the branch. So you need to mention the position of the branch. 3 for dipropyl, and then 1 3 hexadiene. That means we have double bonds here and here. Hexadi and 5 ine, the position of triple bond, 5 position. So this is the name of this compound, and this is the end of today's class, and I do not have time to take your question. So thank you very much and see you in next class.